I'm Brad Beebe. I'm the general manager for the Amazon Neptune service at AWS. And I'm very excited today to be joined by Dave Beckberger, who's a senior graph architect on the Neptune team. And later he's going to show you a demo about how to use a security graph and build one. And also a special treat, we have Ami Lutwak, who's the CTO and co-founder of Wiz, who's an AWS partner and also an Amazon Neptune customer. And they're going to be talking about how they're using a graph to do some really exciting things in the security space. Before we get started, I wanted to get a sense of the experience of the audience. Can you raise your hand if you're building or using security applications today? Okay. How about folks that are using a graph in some form, a graph database, different kinds of graph analytics? Okay, a couple. Good to see you as well. And then anybody using Amazon Neptune? Fantastic. Okay. Customers are excited about graphs. I was involved with Neptune since it was announced as a preview at reInvent. And over time, what we've seen is that customers continue to use more of the relationships in their data to gain insights and apply them to business problems. And this is increasing year over year. There are lots of different use cases for graphs, but the ones that we're seeing the most traction in are using graphs to detect fraud, using graphs to resolve identities or for customer 360 type applications, and using graphs to organize information, often known as knowledge graphs. But the reason that we're here today talking is that we're increasingly seeing another use case, and that's security graphs. And so using graphs models to help people to use relationships in their data to solve security challenges. Graphs and security is really a classic kind of application. It's been used for a very long time. But I think what's changing today is that the ability to use graphs and use graphs as a managed service has made it faster and easier for customers to do so. So security graphs are no longer the domain of very large enterprises or particular government agencies, but they can be applied much more easily. For a quick background, graphs are a data structure. They consist of nodes and edges, or vertices and links. Nodes represent your entities, and the links represent relationships between them. Graph databases can efficiently store and process data that's in a graph data model. Many of us have been in a conference room with a whiteboard, and we've been trying to collaboratively solve a problem. And often what happens is you start writing the things that are important on the board, and you write something else, and then you make a connection to it. And all of a sudden, you've sort of, without knowing it, you've built a graph model. And then in many cases, you go put it in a relational database. We can talk about that later. But in the security domain, it's pretty easy to see how you can think of it as a graph. If you look at the example here, you can see a user. We see things that a user interacts with, file systems, computer, network devices. And so when we have this kind of connected structure, a graph data model makes a lot of sense to represent it. And here's an example of what this sort of conceptual model would look like as a graph model. You can see that the devices become nodes. These things have properties, so I can assign things like IP addresses or MAC addresses or domain names. And I can relate them. I can relate them either via networks or usage different relationships. And those relationships themselves can have properties. So it's very natural to take a security model and apply it as a graph. And it turns out that when you look at graphs in the security domain, there's a lot of different problems that you can solve relatively easily. If you build a graph of your resources in the cloud, you can start to query them and try and understand which ones may have vulnerabilities or where are there places that you can improve the security. If you look at how network flows happen across boundaries or between devices. You can use that to detect exfiltration or other kinds of data flows that you don't want. And so on and so forth. Identity and access management, supply chain security, digital forensics. Where did this file come from? I see this file hash. Where else was it in my network? Those kinds of problems are much easier to look at from a graph perspective. There's also some challenges. One of the challenges is understanding which of the relationships in your security graphs are important. Everything's connected. Which are the connections that you should pay attention to? Which are the things where the absence of a connection should be alerting you to something itself? And so that's one of the challenges. Another challenge is that even for a small organization, these graphs can get large very quickly. And when you think about medium-sized enterprises and even larger, you have to be able to store and manage and query billions or even trillions of relationships quickly and efficiently to be able to solve these problems. And finally, like many domains, the security space, it's important to respect various different legal protections, privacy protections, local government regulations. And so you need to make sure that you have the right infrastructure to ensure confidentiality and integrity in place when you process this data. Here's a hypothetical example about a security graph and how it might flow. If you look on your left, you can see that there's a lot of different assets that you might have in your organization or your company. You have devices, you have applications that are people using. These are all producing various different kinds of metadata. They have different log files. And you probably store that in something like a data lake. Hopefully it's something like Amazon S3. And once you have that data there, you can process it to put it into a format that you can look at as a graph. Now, sometimes that means normalizing the data. Sometimes it's other kinds of ETL things. There's a number of different tools that you can use to do that. So to the middle step, here we have an example of identity resolution, but you often want to apply different kinds of data analytics to the data to help make it easier to process. So these can be things like normalizing different kinds of device identifiers, or if you're dealing with biographic or personal data, trying to identify which identities represent the same people in the real world. But they're important processing steps to improve the quality of your graph application. And then finally, you want to store it. And you want to be able to store the graph in a place where you can query it and access it quickly and effectively. So why would you use a graph database service to store a security graph? You certainly could use a relational database or a key value store, but you find there's a couple of different challenges. The kinds of questions that you want to ask, why is this device connected to this device? What are the vulnerabilities on there? Are effectively traversals. And to implement those in a SQL-based system means that you need to do a number of different joins. Join processing means that the SQL statements are difficult to write and error-prone, and they're often also slow to execute because relational databases aren't optimized for the kinds of graph query patterns and workloads that you see. You can also use key value stores, and you encounter a similar challenge. The lookup on a key value is very fast if you're looking up a particular point. But if you need to do traversals across or do join processing, it becomes very expensive because of the network effects that you get to do that. You can also choose to do a self-managed solution. This can be a great option to get started, but as you grow and expand, it can become expensive and difficult to operate. A lot of organizations don't have the expertise to tune graph systems. And finally, these graphs will grow and shrink over time. So you want to be able to scale your system up quickly and effectively. Amazon Neptune is a fast, fully managed graph database service. Being fully managed means you don't have to worry about provisioning hardware or provisioning instances. You can scale up and down, and you only pay for the resources that you use. The core of Neptune is a purpose-built engine that's optimized for graph processing. It's durable and ACID and provides immediate consistency. And it provides millisecond querying over billions of edges. It also gives you, as a developer, the most choice of graph query languages. Amazon Neptune supports the property graph and the RDF graph models, and we support the choices of the Open Cipher query language, which is now generally available as of today, the Apache Tinkerpop Gremlin language, which is an open source project for property graphs, and the RDF Sparkle language. You can see we have a number of customers, thousands of customers have built applications and are running them on Neptune. And would encourage you to take a look if you're interested in more. And now I'm going to get off the stage and let you see Dave's demo. Thank you.
Thank you, Brad. Thank you for that, that great background on security graphs and security and the business challenges that people are working with today in order to get this up and running at scale. So for the demo I had to show you today, we wanted to look at a couple of things. What we're going to be specifically showing here is a cloud security demo. So that cloud security demo is going to show a couple of different things. It's going to show, we're going to first start off and look a little bit at what your AWS resources look like as a graph. So when you think about your AWS resources, you have things like key pairs, IAM roles, policies, EC2 instances, security groups, things like that. All of these represent entities. These are all physical things inside or assets inside of your network. And these things are all connected in various ways. When we start to look at how these things are connected, we start to build out this graph. And this graph can then be used to help drive some specific insights around what it is that you're doing and how your network is set up, potential vulnerabilities, threat vectors, exposure levels, things like that that people may be interested in when you're looking at a security graph application for your cloud. So let's just start off here, and let's start by just taking a look at what this account looks like. So what we're looking at here is this is what we call Neptune notebooks. This is the IDE environment that we provide for Amazon Neptune. It is an open source package that runs on top of Jupyter notebooks, if you're familiar with those. So you can install this, and it provides basically a set of called Jupyter Magics, which are basically commands that you can run inside there that allow you to easily interact with Neptune. And you can do this, a couple of specific things you can do here. You can run the different queries. It's where we allow you to run queries, see the results, and you can see the results in a couple of different ways. What we're looking at right now is the tabular result. You can also see the raw JSON value that comes back from this, as well as the one that really starts to show a lot of this aspect of graph, which is the network connectedness aspect of this. So what we can see here is, we're looking at this graph of our AWS resources. And this is a very small graph. This, I'm sure most of the accounts that you all are working in have many, many times or hundreds of times the number of assets we're showing here. But this demo is just kind of showing a smaller account and how all of those, even in the relatively small number of assets, how all of these connections start to really build out this web of networks, of a network sort of aspect that you want to be able to see and be able to kind of use for your security graph application. What you're also seeing here, beyond just the visualization, is, as Brad mentioned, the query language you're seeing here. This is the Open Cipher query language. As Brad mentioned, it went GA today. But this is one of purpose-built graph query languages out there that really is very efficient at being able to match patterns inside your data. So you can kind of write a declarative statement of, I want to find everything in my data that looks like this, and this will let you do it. I'm not going to go into the specifics too much of Cipher here, but just so you can kind of understand what you're looking at. Anytime you see the parentheses, that's representing an entity or a node inside your graph. The dashes and the lines represent the connections between things, and anything in brackets is representing the edges, the specific named edges that you're trying to do. So in this case, I'm trying to find everything that's connected to anything else. So this is sort of the fetch the world type query. Works on a small graph, not something you necessarily want to run if you have billions and billions of entities, unless you want to, see a big ball of spaghetti on the screen here. So, with that, what is it that you're able to actually do with this information? Well, one thing that often people want to do with a security graph, especially when looking at it from a cloud security perspective, is you want to start looking for vulnerabilities. Maybe you want to find out which resources are insecure. And have you configured insecurely or incorrectly inside of your AWS account? And a really common way that you see people do this accidentally is they create policies, IAM policies, that are too permissive for the sorts of things here. So in this case, what we're showing is I wanted to find the insecure policies in my thing, and I did that through two ways. I first found any ones that had administrator access. The blanket administrator access policy that comes with every AWS account. I want to see what's using that. And then the other one I'm looking at is I want to see any policies that were created by somebody that has a star in it. The very common use case of don't put stars in your IAM policies. I want to see if anything in this account actually has. So if I go here and I run this, you'll see I'm able to find that information almost instantaneously. And when I view the graph, what I can see is, I have two different policies here that I have the administrator access policy, which we kind of expected, as well as somebody went and created an open S3 policy, giving blanket access across S3 buckets. Not something we probably want to have in any sort of production account here. So, being able to see those policies is one thing, but really the power of graphs comes from not just seeing those policies, but being able to see what's connected to those policies and what you actually are able to do, to be able to start traversing those relationships or looking at the different connections and seeing how they're being used. So in this case, this next query, we're sitting there not only looking at the policy, but we're seeing if there's any roles attached to the policy. Because you might have a policy, it's got a star in it, but it's never being used inside your account. That represents much less of a threat than if something actually is. And if we take a look here, what we can see is that we have, with these policies, we have a couple of different roles attached to it. With the OpenS policy, it's attached to a role called altimeter, shown right here, as well as an OpenS3 role and one called OpenS3 and one called OpenS3. And for the administrator access, we see somebody created a role called I need admin access. This was probably somebody a developer or someone in operations trying to debug something maybe, as well as one down here called admin. So with this, now that we've been able to see that these roles are being used, that there are insecure roles and that these roles are being used, what resources are associated with that? I'm able to sit there, as we can kind of see from a query perspective, what you're doing is really starting to build out a bigger and bigger pattern. So, in this case, I started with the policy node. Now I want to see how that's linked, and now I want to jump out even further and start looking at those different links and those different connections at different depths in order to see what might possibly be being exposed through this sort of interface. When I do that, what I can see is now I have a couple of interesting things here. Not only do I have those roles, but those roles are being used by 3 different EC2 instances. Now, as someone looking at the security of my AWS account, now I'm starting to get worried. Now these are not just being used by ephemeral things. These are being used by long-running compute resources, things that actually people may want to be able to gain access to for illicit purposes, something like that. So let's focus in on that a little bit and see what we're able to do from that. So not only do I want to see that I have those things, but I want to be able to see what those different things connect to as well. So as you can see, what we're really doing is starting to build up these patterns of traversing and connections across things. Not only does this role exist, but this policy exists, but that's connected to a role. That role is connected to an EC2 instance. That EC2 instance is connected to security groups, things of that nature. And you really start to see how you can start to see not just that you have insecurities inside your account, but where those things are impact. What might be an area that, what might be the blast radius, for lack of a better term, of some sort of illicit activity going on if somebody was able to gain access to these sorts of things. So with that, let's maybe just focus in on those EC2 instances a little bit more. As we can see, we can look at these different EC2 instances, and because we're able to actually look at these as a graph, it's not just the connections associated with it, but we also get to see how they're connected. how exactly, what is the exact path or vector from, this Open S3 role, this Open S3 policy to the Open S3 role to the transient access as well as to the EC2 instance. So you can really start to see not necessarily just that you do have a problem, but how you have a problem. And that's one of the real big advantages of something like a graph database, is they don't necessarily just tell you the answer, but they will also tell you how you got to the answer. So you have a way to kind of be able to backtrack from where your answer was back to the starting location. So you can start to do some sort of mitigations, things of that nature. And finally, just because I have an EC2 instance that's associated with a role, a very important question you may want to be able to answer is this exposed to the internet? Because an EC2 instance with an insecure role is bad. One that's exposed publicly to the internet is much worse. It's a much worse scenario to be in. And in this case, we can see that, that 2 of the 3 actually have public IP addresses associated with this. So this is an area where you probably want to start taking a deeper look at these, and not just looking at the fact that I have these EC2 instances and that I have this, but I probably want to start looking at this as a way to be able to mitigate, now that I know I have a problem, how do I go about mitigating the problem? Where do I need to look to be able to find this sort of information? And with graphs, you can do this again just by continually expanding this deep link analysis of your AWS resources. You're able to also see things that show not only do I have this EC2 instance, not only do I have this, this insecure role. This role is associated with that EC2 instance, and that EC2 instance is associated with this specific security group. So now I'm able to also pinpoint where I probably want to go start looking at in order to be able to where I want to start looking at in order to be able, where I want to start looking in order to be able to start mitigating this problem early and often. So with that was sort of the end of the demo that I had kind of planned today. If you're interested in the tools I used here, so the tool I used here to create this graph is a tool called Altimeter. Altimeter is an open source project that is backed by Tableau. And what it does is it uses Boto3, the Boto3 Python client, to scan your AWS account and build a graph of that account. And that data can be stored directly into Amazon Neptune. So if you want to get started today, this is a tool if you just want to see and start with graphs. It's a great tool to use for that. And if you want to start using that today, there is a blog post here about how to graph your AWS resources, where we go into the details of building out exactly the sort of security graph that you saw me demonstrate here today. So with that, I would like to bring out to the stage Ami Lutwak, who is the co-founder and CTO of Wiz. Wiz is revolutionizing cloud security with an agentless graph-based approach. And I'm very excited to hear him talk today about how they're using Amazon Neptune as a critical part of their infrastructure. Thank you.
Thank you. So very happy to be here today. So Wiz is a cloud security solution that is really revolutionizing cloud security using graphs. And I want to explain to you today what we do, why we use graphs, and how we work with Neptune to really change the cloud security market. So I'll start from the beginning. I'm Ami, the CTO for Wiz, and Wiz is a company that's just 2 years old. It's already the fastest growing cybersecurity company in history. We scan billions of files every day. We work with the largest cloud environments in the world. We cover more than 20% of the Fortune 500 cloud environments. And a lot of this is because we come with a new approach to cloud security. And the key of that is actually using the graph, right? And what I want to show you today is why we chose the graph and why I think these graph-based use cases are a way to change how we approach security and maybe even many other areas, not only security. So just a quick word of what Wiz does and how we work and operate. So our approach to cloud security is pretty simple. It's 4 key steps, and each of them is very different from the way legacy solution works. So the first approach is ingest everything across all of the layers of the environment, right? So we call it the agentless scanning, so you can scan everything from the cloud environment even into the workloads. The second step and the third step are actually possible using the graph. So the ability for us to do deep analysis, and we'll look at use cases that we can do today, like analyzing the exposure of a resource, analyzing the actual risk of an attack path in the cloud environment, is doable because we map all of the different feeds that we collect into a graph. And then the third piece is that we show the user what do they really have to fix right now in the environment, and we can do that because we put all of that into a graph, right? And the last part is also a game changer because we can basically split it into sort of mini graphs where each owner is the dev team that owns this environment. We can basically build a tool that can be deployed across any scale and any cloud, then scan it and really analyze the key issues in the environment and have the owners of that environment actually fix the tools. So why are we using graphs? So let's start from the beginning. The way I see it is that really the world is a graph, right? The world is not a table, right? Even if you look not on the security, just even this right now, I'm doing, we are in a conference, right? This is a talk, right? So yeah, you can put all of that in a table, the list of talks. But if you want to really model what's happening, so there is the talk. So and it's happening in a location, right? And I'm part of a company, and the company it works with certain customers, and you can ask questions about the location, right? So you think about it, this is actually a graph. Now, security is just the same. If I want to answer the most important question in cloud security, which is, what are my critical risks in the cloud? This is actually a graph question, right? And there is actually no way to solve this without using this graph technology. And if you look, and we'll now go through use cases for that, but just what's the key question I'm trying to answer? A critical attack path, a critical risk in the environment. Let's break it down to 3 questions. What is exposed for the attacker? What the attacker can actually make use of? What's vulnerable, right? And then what are the risks that you can actually escalate to a sensitive resource? All of these are actually use cases of graph questions. And before we build this in this way, legacy solutions just couldn't answer these questions. So that means that all of the existing solutions today, right, when you ask them what is the critical risk in the environment, they don't really give you the answer. They maybe give you, millions of vulnerabilities you have, but they can't really answer the graph question, which is, what do I have to fix? That's what you care about. Getting 1 million vulnerabilities, and I'm actually saying million because for even small environments, you really do get 1 million vulnerabilities, but you need answers. And the ability for us to answer the simple questions on cloud is only available if you do it using the graph. Questions? Okay, so let's start looking at the use cases. The first basic use case is network exposure, right? And again, this is maybe the most basic question on a cloud environment. What is exposed from the environment, right? Now, most legacy solutions, and again, it's pretty surprising, but even when you show the demo, you mentioned it, how do you know if something is exposed? You check if it has a public IP, right? But that's not true. It's simply not true. Like, if you look at if you try to think about cloud environments, what is exposed to the internet is not what has public IPs. That's not how you build cloud, right? You have a load balancer, right? You have millions of resources behind it. You might have a container within a cluster that has, even within it, has different routing within the cluster, right? So actually answering this question, you need to understand everything in the environment. You need to understand the firewall rules, the security groups, right? The Kubernetes clusters, the peering connections. This is a highly complex question to answer, right? And that is a graph question. And without modeling it as a graph, you simply can't answer it. So security teams today are actually completely blind to the question of what do I have exposed in my environment, because they can't answer this question. And continue to the second use case. Okay, so I want to know what's exposed, but then what is actually risky, right? So if I have a vulnerability, how do I know I have to fix it? So I need more context. And actually adding context is a graph question, right? Because the context can be across very different layers, right? It can be what is vulnerable, but that's just one graph. We also have the identity graph, which is what do I have access to, right? That's another part of the graph if I have high permissions. Another graph is what secrets I have on this instance, right? So these are actually a lot of different graphs that you can put all together across the different layers. But eventually, the question becomes a graph question. Show me a vulnerability that I really have to fix right now, right? And that's really is a graph question. And the third question is an escalation path, right? So what is really critical to fix? If you can escalate from the development environment to the production environment, right? If I have a way to see there is a workload, it's exposed, it has a secret, this secret is actually a production secret, and from there you can escalate to production, I will fix it right now, I will stop everything and do it, but this is a graph question, right? The ability for us to analyze those kind of paths was never possible using security tools because we didn't have this ability to see across environments and correlate all of those different layers. And that's exactly what the graph technology allows us to do, right? So it basically, and that's what you get, breaks down the silos. You don't think anymore in the sense of my Kubernetes scanning tool, my identity tool, my network tool. No, you have your security graph that shows you what you have in the environment, and the true magic is to pinpoint you in what you have to fix, and that becomes just the queries on the graph, right? And it sounds simple, but it was just not possible without using this kind of technology. And just showing you how this looks like in the actual product. So this is an example of eventually a query on the graph. Eventually, the customer gets an issue, right? Gets an alert. But this is an alert that is much more advanced than what we used to call a cloud security alert, right? It's 10x more context because it says it's a highly exploitable vulnerability, it's an exposed VM, and it has high permissions, right? I'm correlating multiple graphs, and I'm even showing the customers, eventually this runs on the graph, they see the graph, right? And it's customizable for them, and they can immediately get these kind of insights, right? And eventually that's what you want, as a security team, also as a dev team, to know what you have to focus on. Any questions so far? Okay, so how does this all work? So we were privileged to work with the Neptune team to really take this use case of a security graph at scale. I think today Wiz is probably one of the largest graph as a service implementations in the world. And it's really thanks to the joint work that we have with the Neptune team in every aspect of the pipeline that we're building, right? And this is huge scale. We're talking about hundreds of billions of triples in the graph. In every data center, we have dozens of data centers. We're ingesting hundreds of millions of objects every day, right? This is a scale of graph implementation that you don't see. Usually what you see in graphs is like the demo we saw, which is nice, but it works for the demo environment. It doesn't actually work for huge cloud environments. And I'm talking about the largest implementations. And what we've done here together with the team is to take every part of what we need to do in a graph implementation that needs to scale and solve it, right? So I'm talking about ingestion optimizations, right? How can I ingest millions of objects? Optimizing the queries themselves, so the work that is going on the DFE, the ability to automatically optimize the query so the customer doesn't need to know a lot about graphs. They use the product, they just get the answers, right? They don't really need to know how to optimize graph queries, right? And so we're doing a lot of work, both on the ability to optimize, and also, from my perspective, from the security side, just to give you another aspect, the fact that we can do all of that natively allows us to be compliant, allows us even to look at more advanced environments and just take the same design what we've done and just run it on GovCloud, for example. What this really proves is that graph technology is ready for mainstream, huge scale implementations, right? This is not anymore an academic kind of exercise. And it really, this also proves that this kind of new capability allows you to really redefine what is possible when you build a tool. And just a few more advanced kind of capabilities that we can do because we have, and we run on Neptune. So basically, we don't look at cloud security anymore in the same view as in the past where you have different scanners, right? We are now flexible. We can take all of the different scanners you had in the past, right? And we just put them all in the single graph. So we basically consolidate everything to a basic question, which is cloud scanning. So identity analysis, right? Data analysis, vulnerability analysis, secret analysis, it's very easy to extend the model where you have a graph because you simply add more components to the graph, right? And that's a critical capability that when you used to build with databases, you couldn't just add another completely new layer, data layer, to your application and just have everything work with it just seamlessly, right? Another really key capability is the ability for us to segregate the graph to the owners, right? You don't just create a huge graph. You have the ability to build access to mini graphs based on the owners. So you can have a dev team accessing the graph and they see only their stuff, right? And they can do self-service. They can fix their own issues, right? And we do that on top of the Neptune graph. And the third thing, which is, I think, very interesting, is that graph doesn't solve over the use cases, right? There's a lot of data types that are not used and are not great with graph. And what we've done is we've built really great integration between RDS databases and graph. So basically, we have the graph to present the state, like I showed you, but also wherever you have data that is not supposed to be on the graph, it's correlated. And there's a lot of really cool use cases that enable us to basically any kind of, if you need high bandwidth streaming outside of the database, we would put it on the database. When you ask questions about critical risks, you would use the graph. Any questions? Great. So really, if I want to summarize the way I see it, I think that graphs today are revolutionizing security because they allow us to answer questions that we couldn't before and allow us to focus on what we have to fix. And again, this is just a quote from one of our customers, but I think it really is a good example of how customers see this in the context of security, right? So it's like social graphs have a huge impact on the way we analyze social the field. In security, once we start using graphs, it allows us to build completely new type of solutions, right? In a way that the solution understands the context of the cloud environment. So anything related to the real risk, right? A real threat. Now you have context, right? You don't just look at the public IP. You really understand what's at risk. And I truly think that because the clouds are so complex today, there is no other way to build these kind of solutions. And I think that this kind of technology is not only for security. I think that once we understand that graph technology is really a better way to model the world, right? This can also change other industries. I think that security is just the beginning. Any questions? Perfect. Great. So I think that's a great segue to give it back to you.
Right. Thank you, Ami. Thanks for that great look at how Wiz is using Neptune and why you chose graph as kind of the foundational technology of your solution. So we've talked a little bit about the business use cases for security graphs. We've talked a little bit about some of the technical challenges. You've seen a demo of a very simple aspect, or a very simple example of how you can use a security graph, what one might look like, the type of insights you might be able to derive from using a security graph, or graph for your security type applications. So what are some resources to get started? Well, but before I jump right into some of the resources, it's actually kind of my privilege today to be able to announce a couple new features of Neptune. First one being, as Brad alluded to earlier, OpenCipher for Amazon Neptune. So OpenCipher for Amazon Neptune is, well, first off, OpenCipher. OpenCipher is a widely adopted open query language for property graphs. It provides an intuitive way to look at your property graph by providing a familiar syntax. If what we saw earlier in the demo, that was an example of OpenCipher. It's very much familiar, or it's very, the learning path forward is much less for someone like business analysts, data scientists to learn something like OpenCipher because of its SQL-inspired syntax. So OpenCipher was announced for Amazon Neptune last July, but it was in lab mode release. As of actually this morning, it is now available for in all regions for where Neptune is supported for production level usage. This has been one of the highest level, or one of the most commonly requested features of Neptune for quite a while. So we're very excited that this is actually now out there. And this is really about giving customers the most choice to build and migrate their graph applications to a highly available, secure, and fully managed graph database. One of the very interesting things here about our specific implementation is if you're currently using Neptune or you've thought about using Neptune before, maybe you have some data loaded in there already, you can actually start using this today without having to reload your data. But between the Apache Tinkerpop Gremlin query language and OpenCipher, they're interoperable over that same property graph data. So you store your data one time, and we allow you the choice and flexibility to choose the query language that either best fits the problem that you're looking at, or best fits the team dynamic that the team and the team skills that you have today. So that's kind of the first announcement that we get to make. So the next announcement that I'm also really excited about is, as of today, we actually now offer a free trial of Amazon Neptune. This is really about allowing you to start building your graph applications for free for trying out some of these things that we're talked about today. With this, this free trial offer doesn't limit the features of Neptune. This means you can choose from any of our other 3 supported query languages. You can use Gremlin or OpenCipher on top of property graph data if you want to, or you can use Sparkle if you're looking at using RDF, the Resource Description Framework. And with this, any customer, this is for eligible customers. For any eligible customer, you can get 750 hours of T3 medium instances, 10 million I/O operations, 1 gigabyte storage, 1 gigabyte of backup, and there are, like I mentioned, there's no feature restrictions on what you can do with that data. So this is a really great way to start out. Start with graphs if you're new to it, or start out trying some of these sort of things that we've shown you today. And finally, this is free from expensive licenses. It's Neptune at its very core is a pay-as-you-go model. So if you're using this in your application and you use those 750 hours, after that, you're just going to pay for whatever resources you used. You don't have to sign up for or lock yourself into any sort of long-term agreement or anything like that in order to get started with this today. So with those announcements over, I wanted to give you some resources that you can actually use to get started. The first resource you'll see up there is the Neptune Notebook. The Neptune Notebook is what I was demoing earlier. That is that set of Jupyter, that is that IDE built on top of Jupyter that's really targeted for the developer experience to be able to write your queries, visualize your results, look at the type of information. We only touched a very small portion of what you can do with that today. Beyond just being able to write and visualize your queries, you can use that to do other things. You can use that to view the Neptune Streams functionality, which is a CDC stream of changes coming off your graph that you can use to trigger downstream workflows. You can use that to build a Neptune ML model. Neptune ML is a feature of Neptune that integrates with SageMaker to allow you building out graph neural networks based on your model to add predictions, machine learning-based predictions to your system. The next link there is a link to the Neptune reference architectures. If you're interested in what it looks like to actually build an application on a graph database, maybe, I know from earlier, a lot of people were new to graph databases. If you're interested in what it looks like to actually build a real application, I suggest going and taking a look at the reference architectures. If you want to see what some sample applications, some sample full stack applications look like, that third link will take you to a GitHub repo where we have a variety of different full stack examples of how to build out specific types of applications. Maybe you're interested in what it looks like to be able to integrate, how you might integrate a chatbot with a knowledge graph, something like that. I know, for example, there is a specific example out there for that type of application for the user. If you're just interested a little bit more in graphs in general, the next 2 links are kind of great ones. The first one is a link to a bunch of example use cases, videos, blogs, things like that that are really helpful to start, to help you get started using Neptune, or to understand what sort of use cases graphs and graph databases are good for and maybe not as good at. And like I said, the bottom one there is a list to customer testimonials and customer success stories. We also encourage you to get engaged with the AWS training and certification content. 2 things we kind of want to highlight here. First is Skill Builder. Skill Builder is an online training center that makes it easy for anyone, be it beginners or experienced professionals, to build their AWS cloud skills. There's over 500 free digital courses on that are really aimed at helping, providing a learning path for you as our customers to be able to get up to speed on best practices for building out applications inside AWS. Within Skill Builder, you can take advantage of a flexible learning paths with suggested digital courses in specific domains or for specific job roles. And as you build these skills, you may want to take advantage of these skill builder classes to look at being able to actually get certified with AWS. We really invite you to enjoy the community of AWS certified professionals here. It's an industry recognized certification that spans foundational, professional, and specialty levels that really validate that you are an expert in the AWS concepts, constructs, and skills that you say you are. With these two things, you get access to a lot of additional tooling, discussion forums, learning and networking opportunities, and challenges, different challenges that come up that allow you to earn rewards and recognition within the greater environment. So with that, I would first like to thank both Brad and Ami for presenting with us today, and I would like to open it up to any questions that may be out there.
So assume the agentless bring out the benefits over instead of those things. But also without agent, it means that delay on certain changes to be detected by your service, right? Because there is no real-time signal. Under this, you may periodically reset, scan metadata of that AWS account to get this extract this information. Does that mean actually there is some kind of delay when you update your graph about a certain account?
So if I can maybe summarize your question for Ami here. You're interested in Wiz's architectural choice of using an agentless approach to being a scanner, and how that may impact essentially delays in the changes and how changes might be propagated into the graph. Is that the?
So I think when we look at Wiz as an example, or in general for graphs, right? I spoke about the interesting integration between other technologies in the graph. So first of all, is a graph real-time? So it can be, right? So yeah, you can look, for example, into the event stream that is coming, right? When an event is coming, you detect there's a change and you put the update to the graph. So definitely it can be real-time or near real-time as needed, right? And also, there's no limitation into what you put into the graph, right? I'm not limited just to get resources, metadata resources. I also can scan the workloads themselves in an agentless manner and put that on the graph, right? So the graph is not limited to just grabbing from APIs. That's the beauty. You can see basically everything on the graph. Even you can be on the graph, right? Why? Because you push code. So, and the code becomes a vulnerability. So I want you on the graph. So basically, think about multiple sensors that are working together. They can feed from real-time streams as well as offline streams. The beauty is that it doesn't matter. Eventually, you have the current state on the graph.
So just to repeat the question, just so everyone can hear it, the question was, is there any TPS limits to the amount of updates you can add to the graph?
So there is, so a lot of the optimizations also that we work together with the Neptune team, right, is around optimizing ingestion, right? And there's a lot of work that we do both in the sense of how can we optimize, and basically all ingestion that we do will be based on the optimized keywords, right? And also we do a lot of effort on modeling the graph in a way that it's very, very efficient, right? There is a lot of details of how you do all of this magic without going into the problems of actually building an inefficient model, right? If I would try to put an edge between every VM and every other VM that have access to each other, that would never be able to scale, right, and work in these real-time considerations. But it's about using really optimized ingestion, but also building the right model.
demo you showed on the Neptune, do you have any plan to add as a feature under the services? For example, if I go to under VPC, if I click, there is a generate a security graph. It will show me the graph of under that VPC. Is there any plan on the roadmap? Rather me going under in a Jupyter, doing all these queries, it's easy. You know what I mean?
Yeah. So the question was, for the security graph use case that was exposed, is there any plans to add that as a feature?
I think that we're always looking at kind of working backwards from what customers are interested in, and we're really interested in how we can use graphs to help customers secure their AWS resources in general. So we don't have specific plans for that feature, but we are looking at things that are similar to that.
Yeah, I mean, that helps, like, for example, if I create a dev environment, I can take a template or how it looks like when I compare to production, because I need to clone it. It's basically clone, but it will be easier for us to navigate. Another question is, can you add more metadata on the nodes? When I click the node, say EC2, can you give a big
Yeah, I didn't demonstrate that. So the question was, can you add more metadata on the nodes? So when you were working with a labeled property graph, it had both, those nodes contain not only the fact that they're a node, but they have a thing called a label, which is you can sort of think of as a group that they belong to, as well as a variety of different properties associated with them. So you can assign properties to nodes, but one of the unique aspects of graphs is you can actually assign properties to the edges. So you can assign properties to the relationships between items. So I like to think of it as, I often say, working with graphs, edges are first-class citizens, or relationships are first-class citizens, because those, not only do those get to have properties themselves, but they're also, one of the big differences between something like a graph database and a relational database is those edges are actually materialized, they're stored to disk. So one of the reasons graph databases are great at traversing edges is because it doesn't have to calculate those at runtime. If you do something like a relational database, it has to calculate those relationships at runtime, whereas graph databases, we've already calculated them, they store it on disk, and it makes that very efficient to be able to traverse across those or move across those. Sorry, the second one was syslog?
Syslog.
So the question was, what is the level of effort or complexity around integrating things like CloudWatch logs or syslogs into Neptune, into a graph environment? When you start looking at something like that, it actually becomes a very interesting problem, because what you really want to do there is not necessarily integrate specifically just the CloudWatch logs. You want to integrate the associations inside those CloudWatch logs. And that's really where the graph comes into it. This is sort of a lot like we see a lot of things for like IoT use cases. You don't necessarily want to integrate necessarily each log or each event in a CloudWatch log into a graph, because graphs, just by their very nature, the amount of time any traversal takes is really associated with the amount of the graph you have to touch. And if you have to traverse 10 million edges, it's going to take longer than if you have to traverse 1 million edges to get the same sort of answer. So in those sorts of scenarios, we actually really often look to integrate something like CloudWatch logs. We want to pre-process them and integrate essentially the connections between the events into the graph, but the logs themselves you would want to store in a different sort of system. Same thing with like syslog, things like that. Any sort of log or IoT time stream type data, you don't want to just take that and dump it blatantly into a graph. You really want to extract out the key relations in those things.
Yeah, the level of effort from a integration perspective is relatively low. What's important is the thinking about what are the questions that you want to answer from those CloudWatch logs, and that's where some of the pre-processing comes in.
Yeah, the temporal aspect there is also key, yes. Any other questions? Oh, sorry, thank you.
You need sunglasses.
The open source, which database?
I think the question was, how is Neptune compared to the open source Neo4j version? Is that correct?
Okay, thank you. So Amazon Neptune is, probably the biggest difference is Amazon Neptune is a fully managed service. When you start up a cluster of Amazon Neptune, you're already getting, a highly available distributed storage aspect to it. Because we're purpose-built database for the cloud, we're actually able to take advantage of some of the cloud-specific aspects. We're actually able to separate out our compute layer from our storage layer, allowing you to independently optimize both of those. So we didn't go into quite the architecture of Neptune, but Neptune has an instance-based model where you're able to horizontally scale reads and vertically and horizontally scale both reads and writes by choosing different instance sizes. So that compute layer all sits on top of a cloud-native storage layer. When you write data into Neptune, it's written 6 times, twice in each of 3 availability zones. So kind of out of the box, what you're getting with Neptune that you don't get with some other database providers is that really production-ready type of infrastructure. You don't have to, build your application and then go through the process of actually productionizing it. You've already built your application is already built with a production-ready type of infrastructure. And that's probably one of the things I would say is one of the biggest differences, that fully managed aspect of Neptune versus some others.
I can add, like from our perspective, is like if you want to build an application at scale, right? I think building that on an open source tool, if I compare, like if we had chosen to build that on an open source library, we probably need like a whole team that would just try to manage that and create more features that are missing, right? So if you plan for huge scale, it's a huge help that there's an entire graph as a service team that helps you scale as you need, and not you becoming the one that actually has to really understand all of the complexities about scaling that.
Well, sorry. We'll be around here, but we're getting the cutoff signal. So
Why don't you come up afterwards? And
yeah. So if you want to come up, we definitely can answer all your questions. And I want to thank everyone for coming to our presentation today. Thank you.